Today we need to talk about parent functions. So if you read this little paragraph with me, it says groups of functions that have common characteristics are called families. Each family has a parent function, which is the simplest function in the family. The rest of the family are transformations of the parent, like the example shown. So we have the parent function of y equals x squared. That is the quadratic family. Okay? You might also remember that the quadratic family, its graph is called a parabola. Now, y equals x squared is the simplest quadratic you could ever get. You have to have those elements in order to get the parabola shape. So you have to have x squared. If you change the x squared, let's say you multiply or add or subtract or divide things from it, you still have the shape of the parabola. See, all of these are still parabolas, but they're moved different places. So if I add 2 to the back of x squared, then my graph moves up 2. If I subtract 2 from the end, it goes down 2, but it's all still the parabola shape. So the other transformations, if you add 2 inside of the x with the parentheses, you're going to move to the left. If you subtract 2 inside of the function, you're going to move to the right. If you divide or multiply by a number smaller than 1, then you have a vertical shrink. If you multiply by a larger number, you have a vertical stretch. Another transformation you might see is if you take the parent x squared but you negate it, so you have a negative x squared, that graph is going to be the same as your original, but the negative is going to flip it upside down. We call this a reflection across the x-axis. So when you start with the original and flip it, then you reflect. So that's just kind of a good introduction to parent functions. Now, the other thing I need you to remember, because a part of your assignment today talks about the quadrants. Remember that quadrants in graphs are labeled with Roman numerals. Quadrant 1 is the top left, and then it goes in a circle counterclockwise. Quadrant 2 is the top right. Quadrant 1 is the top right. Quadrant 2 is the top left, like I've written it here. And then just keep going around. So make sure you've got that written down just so that you kind of remember that idea. All we're going to do today is I've given you the name of the family, and I've given you the parent function equation. So for all of them, what you're going to do is you're going to take the table that I've started, you're going to find the y values, then you're going to plot the points and connect them, and then give the domain and range, okay? So these x values that I picked, those are just random x values that I could pick to go on that equation. But if all you know is the equation, there's really infinite x values I could have picked to get a good shape. So we're just using this table not to tell us the only points, but to tell us what shape we need to follow in order to connect it, okay? So linear is pretty easy. I've got y equals x. Well, if x is negative 3, then I'm going to do a y equals. Instead of x, I'm using negative 3, so y is negative 3. I've got y equals, instead of x, we're using 0, so y is 0. Y equals, instead of x, we're using 4, so we have 4. So when you substitute the values into the original parent function, then you get the y values out. So now we're going to plot those points, negative 3, 0, 0, 4, 4. Then remember, there's more points on this equation than what we have. We just needed a good idea of what it would look like. So now we will connect the points as best we can and describe the domain and range. So in set notation, our domain goes from negative infinity to positive infinity. In interval that's not set notation. That's I meant to change this. Instead of set notation for all of them, I want you to do interval and inequality. So interval notation, negative infinity to infinity. Inequality notation, all of the y values are stuck in between negative infinity and positive infinity. So for all of these, instead of set notation, I want you to use inequality notation. So carry that down, my bad. Okay, the range, Oh my gosh. We were talking domain, so it should be the x's. The range, though, is the same. My graph goes forever down and forever up. So we say that it's negative infinity to positive infinity. Okay, the absolute value graph. Absolute values make anything you put inside a positive number. We want, absolute value really means you want to know how far away from 0 that you are. So if we have y equals the absolute value, instead of x, we're going to use -3. That's +3. If y equals the absolute value of 0, that's 0. Y equals the absolute value of +3 is +3. So we've got -3, 3, 0, 0, and 3, 3. So this graph makes a V. That's the absolute value parent function. So again, instead of set notation, we're going to use inequality notation. All right, so my domain, my x's, are going to go forever left and right. So I have negative infinity to infinity. My range, though, the range, the y values, they're going to go, all the y values are stuck in between. 0 is the lowest, infinity is the highest, and I have a point at 0, so I'm going to include it. So we say that the interval notation is a bracket 0 to infinity. Okay, now quadratic, you already have up here, but let's talk about how we get the points. The main thing to remember with quadratic is when you square a value, you have to put it in parentheses. So we're going to take y equals, instead of x squared, we've got -2 squared, which is the same as saying -2 times -2. It's +4. -1 squared is really -1 times -1, 1. 0 squared, 0 times 0 is 0. 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. So we've got -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. And you know that quadratics make a parabola shape. Remember, instead of set, we're using inequality notation. The domain of this graph is going forever left and forever right. So we have from negative infinity to infinity. The range of this graph is going from 0, and it can be on 0 to infinity. So we have bracket 0 to infinity. Okay, so I think you kind of get the idea. So what I want you to do is I want you to do the rest of them, okay? And see what you can come up with. Let's go down here to exponential and logarithmic. Now, exponential and logarithmic, the parent function has two variables. They use a b and they use an x. So all we're going to do is I've given you the shape of that graph. Both of these graphs have what's called an asymptote. Exponential has an asymptote on the x-axis,